Alright, so here in this I'm going to do a just full recap of the quiz that happened for those who were either absent for a couple days and need to look back over this, or people who need to review this to do the retake. Alright, so let's go ahead and jump in. So stating the dimensions of a matrix. Remember, it's RC car, RC matrix, so I need to talk about my number of rows first. I've got 2 rows, and then 1, 2, 3, 4 columns. That's a 2x4 matrix. Over here we got 3 rows and 1, 2 columns. Alright, so adding up matrices when we're adding, this is literally putting the corresponding numbers together. So like top left, top right, all the way down. So I'm going to go ahead and just fill these in. And that's what they would look like if you were to add all these up. So do just keep track of positives and negatives. You know, this is a -1 plus a 6 to give me that 5. Okay, so on this one here, since you have to add corresponding elements, you know, I've got a top left and top left, but then it kind of breaks down from there. So these are not the same size. In order to add matrices, they must be the same size. So I can't do it. I can't add or subtract those. This one here, I just recently tossed in these negatives. Let me kind of take these away there. Those weren't on your all's quiz. But when we go to subtract, you got to think through a little more carefully. So I do 2 minus 5 to get a -3. Then -2 minus 3 to get the -5. So you want to be careful that you are subtracting each time. 6 minus 1 to get the 5. And then so on and so forth. So there is that. So just make sure you really keep track of what you're doing and how it would change your numbers. And ignore these negatives that I crossed out for you guys right here. Those weren't on your all's quiz. Alright, so these are the ones where people really started to struggle. So let me start off and talk about some of the things that we cannot do. Some people were trying to do this. They say, okay, well, here's this 2. Can I get rid of it by just multiplying by 1/2? The reason I wouldn't want to do that is because if I try to multiply by 1/2, that means I need to multiply this one by 1/2 and that one by 1/2. Because when I multiply, I must multiply by everybody. So that wouldn't be one of the options I'd want to take on. Same thing for why I wouldn't just want to multiply right now everybody by a -1/3 to cancel out that -3, because then I'd have to do that -1/3 to this matrix and that matrix, making too much work for myself. So instead, let's focus on clearing this part using addition and subtraction. I would need to multiply in that scalar, though, to get 0, 2, 6, -8. Now minus 3x is equal to our matrix here. Alright, now I can do this. I can simply subtract this matrix from both sides. Okay, so when I do that, what that will leave me left over with is I've still got -3x is equal to. So now I'm just going to take this matrix and subtract that matrix. Okay, so I've got 9 minus 0 to get our 9. I've got this -6 minus 2 to get a -8. 1 minus 6 to get a -5. And -2 minus a -8. That's a double negative there. So -2 minus that -8 is really -2 plus 8 to land me at 6. Okay? Now we are able to multiply both sides by our -1/3. And I'm choosing -1/3 because that'll get negative to cancel out with negative, the 3 and the 3, getting my x by itself. Which means over here on this side, I also need to multiply all of these values by, and I left off my negative sign, by a -1/3. And that will tell us our answer. So I'll get a -3, I'll get a positive 8/3, a positive 5/3, and then a -2. Alright, so take these step by step. Try to save multiplying everybody on both sides until the end. You know, go ahead and multiply that scalar in. That's going to be easier than multiplying everybody by 1/2. All right. This one here is actually more simple than that. I just need to add that matrix to both sides. All right, 3, 4, 2, 1, and 9. Add that over here onto this side. Okay, because these will cancel out because it's one of them's negative and one of them's positive. All of those are gone, freeing up my x. And then now we're just adding corresponding values just like we did up top. So whenever I just add this matrix and add that matrix together, here's what we get. There would be our answer there. Okay. Solving for the following variables, and I asked for us to show our work. So the way this works is I just need to find x and set it equal to the corresponding value on the other side. However, these matrices need to be added together first. So if I do that, I'll have 8, a -1, a 6, and a 3. Now that is set equal to my 8x, y, and z. And you can see very easily what corresponds with what. X is a -1, y is a 6, z is a 3. All right, pretty straightforward on that one. Just make sure you combine here first. That way you can set up a 2 by 2 equal to a 2 by 2. Okay? This one we don't have to do any solving, at least at first. I can go ahead and set up corresponding values. 2x is equal to 18. That makes x 9. Then I've got 3y minus 1 is equal to 11. Add 1 onto both sides. Divide by 3, and we get our y is equal to a 4. Okay, so there's the front side. Let's check out this back side. I'll do them all by hand. You got to pick which one, but I want to make sure that the work is shown for all. The dimensions, these are both squares, so it's easy, 2 by 2. Since these match up, that tells me that they can multiply. This will tell me the dimensions of my answer. So I know over here for my answer, I'm expecting a 2 by 2 matrix. All right? So here's the way it works. We're going to take this first row, multiply it by this first column. So we'll have 2 times 0 plus, because you always add the second piece, -1 times -3. And I'll go back and simplify that at the end. Okay? So once we have that there, now we are looking to, that's not what I wanted to do. There we go. Okay. Now we're going to take a look at our next combination. So I got this row by this column. And so that will be, we've got a 2 times 4 plus a -1 times 1. All right, it's getting a little big here. And if we just proceed on with this pattern here, to find the lower two values, we've got this by that. So what have we got? We got a 5 times 0 plus a 3 times -3. And then the last one would be this. We'd have a 5 times 4 plus a 3 times 1. Okay, so if we just simplify these, and they're all color-coded in terms of how they'll land over here in my final answer. So I'm just going to add all that up mathematically. I've got a 0 plus 3 to get a 3. Add this one up. I've got an 8 plus a -1 to get a 7. All right, then here I've got a 0 plus a -9 to get a -9. And here I've got a 20 plus a 3 to get 23. And there's my answer. And you can double check that with your calculator. Next one here, I've got a 1 by 3 and a 3 by 1. This tells me that they can multiply. This tells me that my matrix answer is going to be a 1 by 1. So I'm expecting just one answer here. And here's why. These are already matched up, one row by one column. So here we've got this. I've got a 2 times 2 plus a -1 times a -1 plus 6 times 6. All right, and all of those get added together because it's just a row by a column. When I put that together, I get a 4 plus a 1 plus a 36. That would tell me that my answer is just a 41. And that's a 1 by 1 matrix, just like we knew it was going to be, because of this 1 by 1 tells me the dimensions of my answer. All right. This last one here, we've got a 2 by 3 and a 2 by 1. These don't match up, right? So we could say over here something like this. The interior dimensions do not match. A's columns do not match up with B's rows. 3 is not equal to 2 here. Those cannot multiply. All right. So this is just going back to writing it as a system. Don't forget to put your equals bar in there. I've got 1, 1, negative 1. Just looking at my coefficients. 3, negative 1, 1, and 4. And let's see. So then here I've got 5 x's, 0 y's. Notice that there's 0 y's there. 1 z, and 7. All right, this one here, same concept. I'm going to get our matrix. I'm going to write in our equals line. I got a 4, 1, 16. Writing out the coefficients, 2, negative 1, negative 1. Negative 1, 2, 1. 3, 1, 1. If you type that matrix into your calculator, which would be a 3 by 4 matrix, let's just say you called that matrix A. If you then go through the buttons to do the RREF matrix A, you should get something that looks like this. 1's down the diagonals. All right. It won't put you in the equals line, but then it would have a 4, 1, 3, telling me that my solution is 4, 1, 3.